Hello, my name is Ronaldo Sosa, and today I will be explaining to you the development of the project for Unit 3 of Peripheral Programming subject. We were required to automate a model filling process using LabVIEW tools and implemented a DSC module. This module gives us an image navigator, which I use to substitute elements into the tanks and pipes you can see on the interface. In the process, we have 4 tanks that were created with vertical fill slides. Vertical pipes were also created with the same slides. However, horizontal ones were made from horizontal fill slides. Elements such as the fan, the mixer, and the bulbs were created using Boolean LEDs. Nevertheless, only the first 2 elements were included into the programming structure operations, meaning that they had a movement effect. Programming structure, as complicated as it might look, is very simple once you understand what happens. We have 5 actions or sequences that correspond to signals read by the Arduino board. These actions are delimited by case structure. Inside of them, we can see operations performed, retrieving data from special tags called local variables. They are located outside of the while loop and indicate given start values that the element will have at the beginning of the process. These operations are simple to follow. They just take the value that the local variable has and create the operation with it. For example, the local variable of the main tank starts at value 10 and is subtracting 0.1 every time the sequence is repeated. I integrated another case structure to create a sequential effect for the pipes. This was repeated 4 more times and will be more understandable when the video gets played. To create the moving effect on the mixer and the fan, a NOT gate was used to operate with their local variables, creating with that a true-false loop. You cannot see it here in the video, but the assignation of the Arduino pins are above the link's terminals. Pins from number 2 to number 11 were used, and even numbers were used for read and odd for write. This is the circuit I built to control the sequence. Basically, I control it with a 8-position dip switch. Each position corresponds to a case structure. Once the switch is triggered on, the valve moves in the sequence and lets the liquid flow. LEDs were included as indicators. They will light up when the switch is in a true state, otherwise they will remain off. Each LED corresponds to a given switch and are also labeled with matching cable colors. Now you will see the sequence and how it is implemented with the physical circuit. So that will be it on my behalf. I hope you have learned something, and thank you very much for your attention. We'll see you next time.